This is a video looking at precipitation reactions for the Year 10 chemistry course. So a precipitation reaction is generally when you've got two soluble compounds that react to give something that's insoluble and something that's soluble. It's also called a displacement reaction. I'll explain why in just a sec. So in precipitation reactions, you've basically got ions which swap places. And it helps to illustrate this with an example. So suppose you've got potassium iodide reacting with silver nitrate. Now I should emphasize here, so anything that's soluble is typically aqueous, something that's dissolved, right, in something else. Something that's insoluble is typically a solid, okay? And the insoluble compound, that's called the precipitate, hence precipitation reaction. Okay, something that's solid, something that doesn't react, and you get something that's aqueous. Now, displacement, why is it called a displacement reaction? Well, because, use a different color here. The potassium swaps with the nitrate, and the silver swaps with the iodide. So here's where you get, in turn, you'll get potassium nitrate plus silver iodide. Okay, so it helps to sort of picture what's happening in terms of ions. So potassium as an ion. So potassium iodide is a neutral compound. Okay, it's neutral overall, it's got no charge. However, it's made of ions. Okay, it's an ionic compound. Okay, compounds are neutral. Ionic compound, why? Because potassium is a metal and iodine is a non-metal, Nm. So potassium has the symbol K. It's got a charge of plus. It likes to give away electrons and hence become positive. It's in group 1. So that's why it's got plus 1. Iodine is in group 7. So it's I minus. It's got a charge of minus. So iodine's a non-metal. Plus silver nitrate, silver Ag plus, okay, it's a transition metal. Nitrate, NO3 minus, okay, it's a polyatomic ion. Poly means it's made of 2 or more different elements, so nitrogen and oxygen. Now, if you picture this in terms of ions swapping places, so the potassium dissociates. So dissociate, okay, you often hear this term in books. Dissociate means to disconnect or separate, okay? When you put potassium iodide and silver nitrate, when you mix them together, in, let's say, a beaker, the ions will rearrange themselves. They'll dissociate, they'll split, okay? Each compound here, each ionic compound, the potassium iodide splits into its constituent ions. Same thing with the silver nitrate. So the potassium iodide dissociates, the potassium then links with the nitrate ion, and the silver links with the iodine ion. And what you get in turn is this. You'll get K plus linking with NO3 minus, and you'll get Ag linking with I minus. Now, this will make sense when I talk about what's actually happening with these equations in just a sec. But this is the idea with precipitation reactions. You've got ions swapping place, okay, linking up with different partners. I'm now going to do this example in a bit more detail. Okay, so let's suppose in an exam we're asked to write chemical, complete ionic, and net ionic equations. A net ionic equation for this reaction. So step 1. So let's rewrite this here. Potassium iodide. Try and write as small as I can to fit everything. Plus silver nitrate. So let's suppose in an exam they ask you to find out what the two products are. These are the two reactants. Let's suppose these two are aqueous. What do? Well, we swap positions. So the potassium swaps and it goes with the nitrate, and the iodide swaps to go with the silver. So you will get potassium nitrate plus silver iodide. And here is where you have to figure out which product is the precipitate. Well, according to the solubility rules, so you can look these up, solubility rules, I'm not going to go through these in the video. Solubility rules basically dictate which ions are soluble and which aren't. Now, if you look at the solubility rules table, given to you by a teacher, or if you go onto Google, silver is insoluble. So therefore, silver iodide is the precipitate. It's the insoluble compound form. So you put an S, okay, in brackets, put aqueous here. Okay, S for solid, right? So that's step one, to find out what the products are. Step two is to write this in terms of a chemical equation. So chemical equation, I should say balanced chemical equation. Well, actually, I'm just going to write ion equation for now. Let's rewrite one in terms of ions. So potassium from before is K plus, iodine is I minus, plus silver, which is Ag plus, nitrate is NO3 minus. That makes potassium nitrate K plus, NO3 minus, silver iodide Ag plus, I minus. I'm going to start here. Now we're going to crisscross, if you recall. Okay, to write a ionic compound, you need to crisscross. Okay, in other words, bring the valencies down. Okay, number 3, crisscross. What we do is, so in the case of potassium and iodine, the plus and minus cancel out. So you get Ki. Let's make sure we write the states. So aqueous plus. Same thing with silver and the nitrate ion, AgNO3. Same thing with potassium nitrate here, Ag. So lucky in this case, it's nice and simple. The rule is, remember, if the superscripts have no, if they're the same, there's no number, let's say, after the sign, the plus and minus, you just don't bring anything down, right? Write it like this. Number 4, let's write the balanced chemical equation. Okay, it's generally not many steps involved in this process, but I'm showing you, I'm deconstructing this question step by step just to make it easier. So let's balance this. Let me draw a line here, separate the reactants from the products. Let's take an inventory. First step, let's write K from left to right. There's K, there's I, A, G, N, O. Okay, there's 5 elements. Same thing on this side. It has to be the same. Okay, make sure to write them in the same order because of conservation of mass. Okay, there's got to be the same elements on the left and right hand side of this reaction. Now it's the counting game. Let's count the potassiums on the left. There's 1, iodine there's 1, silver there's 1, nitrogen there's 1, oxygen there's 3. On the right, potassium there's 1. There's 1 iodine. There's 1 silver. There's 1 nitrogen and there's 3 oxygen. So in this case, the equation is balanced. Okay, it's always important to do this to show the examiner, even if you know from just by looking at an equation that it's balanced, it's also good to confirm that it's balanced. Okay, so that's confirming that it's balanced. Number 5 now, step 5, is to write the complete, what's called the complete ionic equation. What does that mean? Well, we're now going to write it. What I've got here, ionic equation, write it like this. Okay, plus I. So just splitting it, ions apart. NO3 minus plus AgI. Here's where you should be careful as well. I tell my students to be very careful. The precipitate does not dissociate. In other words, the precipitate stays as it is. Okay, it doesn't break up into ions. It's a solid, right? That's the complete ionic equation. The last step, typically, is to find the net ionic equation. Okay, this is like an equation in maths, right? You've got potassium. You can cancel out, right? You've got potassium on the left, 1 potassium ion, 1 on the right, they cancel out. You've got 1 nitrate on the left, 1 nitrate on the right, cancel out. And whatever you're left with, that's the net, that's the total ionic equation. So you've got I minus plus Ag plus, I should also write the states here, aqueous, they're both aqueous, makes AgIS. Okay, the potassium and the nitrates, these are called spectator ions, okay? Because they don't react, they just pretty much sit there in the reaction. This is your final equation. It's showing the formation of silver iodide, AgI, that's the precipitate. Let's do another example. Okay, it's the same idea from here. Let's do aluminium chloride reacting with sodium hydroxide. What does this make? Well, this is a precipitation reaction, so we've got aluminium going now with hydroxide and the sodium with the chloride. So you have sodium chloride plus aluminium hydroxide. Now, to work out what's the precipitate, let's put aqueous here, aqueous here. From intuition, you would know that sodium chloride is table salt, and table salt is soluble. Okay, it dissolves in water. So therefore, the aluminium hydroxide is the precipitate. Okay, and from the solubility rules, sodium is also it's soluble. Right, it's a group 1 element. Let's write the chemical equation. Okay, the balanced chemical equation. Well, I'm gonna skip a few steps here. Okay, aluminium chloride. So aluminium is Al. Use a different color. Al3 plus. Right, it's got a group. It's got a charge of Al3 plus. Chloride is Cl minus. Sodium is Na plus. Hydroxide's OH minus. Okay, back to what we had before, NaCl, Al3 plus, OH minus. Okay, so let's crisscross AlCl. So the 3 comes down to here. This is aqueous plus sodium hydroxide is just NaOH, right? Makes sodium chloride, NaCl, that's aqueous, plus aluminium AlOH, putting brackets 3. Okay, bring down the 3. S. Okay, chemical equation. Is it balanced? Let's see. AlCl, NaOH. Same thing on the right hand side. There's 1 aluminium, there's 3 chlorine, 1 sodium, 1 oxygen, 1 hydrogen. 1 aluminium, 1 chlorine, 1 sodium, 3 oxygen, and 3 hydrogen. So what do we do to balance this? Well, to turn the 1 chlorine into 3, we have to multiply by 3. So we put a 3 out the front here. Now the sodium now becomes 3. All right, let's cross that out, put 3. How do we get 3? Sodium on the left, multiply by 3. Put a 3 out the front. So now there's 3 oxygen. And there's 3 hydrogen. And it's now balanced. Okay, that's the chemical equation. Let's now write the complete ionic equation. Complete ionic. How do we do that? Well, we break apart all the, so we've done the hard bit. Let's break apart now the compounds, the ionic compounds we have here. AlCl3 plus Cl3. So we have to be careful here. AlCl3 is Al3 plus, right? Plus 3 Cl minus. A lot of my students get confused with this. There's nothing to be confused about because that's like saying there's 3 chlorine ions, right? That's what the 3 means, the subscript. Okay, plus 3 Na. So think of this as like 3 times NaOH. So there's 3 Na plus 3 OH minus. That makes, let's write the precipitate AlOH3. Okay, leave that alone. Plus, same thing as before here. 3 Na plus 3 Cl minus. That's the complete ionic equation. Now, let's now find the net ionic equation. Okay, easy bit, easiest bit, I'd say. Well, the chlorines cancel out. That goes. The sodium cancels out, and we're left with this. Al3 plus aqueous plus 3 OH minus aqueous makes aluminium hydroxide. Okay, spectator ions, we cancel them out. And that's how you write precipitation reactions.